Hello there. We're going to show the process of manually calculating some inverse matrices. Now, first thing is, what's the equation? What are we looking for? This matrix must be a 2 by 2, but I don't know what the entries are. So, let's put variables in there. Now, I ask myself, how is this entry 1 generated? Well, it's row 1, column 1. So I'm going to write out that equation. Then I'm going to do the same for this 0 over here. And then we'll get those last two entries too. So I'm left with 4 equations, 4 unknowns, A, B, C, and D, but they chunk themselves rather nicely. AC is over here, BD is over there. So I solve with elimination. So I solve for all the individual entries A, B, C, and D. Now let's combine that back up top. The inverse matrix of this 8, 5, 3, 2 is this guy over here. And we got the work to back that up now. Okay, much bigger problem over here. We're just going to show how you could set this up. First we want to know this times some matrix is the identity matrix. Write that out. The size of this thing needs to be a 3 by 3. The identity matrix expanded to be as big as it needs to be. 3 by 3, 1's down that major diagonal, 0's everywhere else. And we don't know what any of these entries are, so we'll put variables in there. Ugh, it's getting kind of big. Okay, how do we create that first entry? Row 1, column 1 is created by row 1, column 1. Now, row 1, column 2 is made from row 1, column 2. And then we get the last guy. So that was just how we got the entries 1, 0, and 0 there. Now we need to use this row to get the entries here, here, and here. And this row to get, finally, those. So we got 9 equations, 9 unknowns, A, B, C, all the way through I. This equation's set equal to 1, this equation's equal to 1, this equation's equal to 1, and all the other ones are the zeros. That's that matrix there. So how do we solve this? Well, it chunks itself nicely. This breaks into a linear system. 3 equations, 3 unknowns. 3 linear systems, each with 3 equations, 3 unknowns. So I just need to solve all of these systems. Right. And this is what the calculator is doing. So I type in that 1, 2, 3, 1, 1, 1, 2, 1, 1, take the inverse of it, and evaluate. This one actually winds up being whole numbers everywhere, which is kind of nice. They don't normally turn out to be so clean. Oftentimes there's going to be fractions in there, and other times there may not even be a multiplicative inverse at all, but we'll look at that in the future. Character and scholarship for life.